So in this video we will see the concept of relations and functions, and the subtopic in this video is types of relations. So there are three types of relations. The first one is reflexive, the second one is symmetric, and the third one is transitive. Now what is reflexive? Now to explain you what is reflexive, I will take an example. For explaining reflexive, I will take it as A into a Cartesian product. It will be A into A. Now let A is equal to 1, 2. Fine. Now this reflexive is nothing but the relation should be the doublet. It should be the doublet, and for all A belongs to this set A. Now what does it mean? If I do the Cartesian product for this, you should get the same elements. It should be doublet. So 1, 1, 1, 2, 2, 1 and 2, 2, right? But this and this is known as the reflexive. Now what is reflexive? You should tell 1, 1 and 2, 2 because it is the doublet. Well, that is reflexive. Now we will see what is symmetric. For A comma B belongs to R, then B comma A should belongs to R. Now it is like if 1, 2 is there in the set, so it should be that 2, 1 also should be present in that. Now if it is not present, it means that it is not symmetric. So for example, if I take this set, this, as I told you, we are taking A into A and doing the Cartesian product. So the set would be 1, 1 and then 1, 2, 2, 1 and 2, 2, right? Now here this and this is the symmetric, this is reflexive. Now it should not have, if 2, 2, for example 2, 2 is not present in this set, so this set would not be called as the reflexive. If here 1, 2 both elements are present, here in the first set 1, 2 both elements are present, so hence it should be the doublet of these both, then it is known as reflexive. And when it is symmetric, when these both elements are vice versa, 1, 2, 2, 1, it should be present in that way. So that is known as symmetric. Now what is reflexive? Let us just see in a while. Sorry, I mean the transitive. So in transitive, for A, B, C belongs to the set. Now in this A, B and B, C belongs to R. Now what does this mean? Whatever is the last element here, that should be the first element. Okay. Now that should be the first element, and we will get the answer for this as A, C. We have to cancel these both. If you should first choose the set in that way that the first element and the last element should be the same, and then just cancel it. Whatever is remaining, now here A, C is remaining, right? Now this A, C will be the transitive. Now if this is present in the set given, that would be transitive. Now let us see with an example what is reflexive, what is transitive, and what is symmetric also. Now I have this is one of the set and this is one of the set. So now I should first find the Cartesian. 1, 3, 1, 2, and then 2, 3, 2, 2, 3, 3, and 3, 2. Now first one is reflexive. Now is it reflexive? First we have to find the doublet. So for 1, do you have the doublet? Now we can see that 3 is present. Yeah, we will have 3 here. Yes, it is there. 2 is present. Yes, it is present. Now 2 and 3 is present, but 1 is not present, right? The doublet of 1 is not present. So hence this is not a reflexive relation. This is not a reflexive. Now reflexive, wrong. Now let us say if it is symmetric. Now 1, 3 is there. Is 3, 1 there? Yeah, it is not there. 1, 2 is there. 2, 1 also is not there. 2, 3 is there. 3, 2 is there. Now these both are reflexive, but we are seeing for the whole question. So hence 1, 3 to 1, 2. For this symmetric is not there. So hence it is not symmetric also. Now let us see if it is transitive. Now, well, if it should be transitive, what did I tell? I have to choose the element such that the first element and last element should be the same. So, if I take 1, 3, then I can take 3, 2. See here, this 3 is present in the last and this 3 is present in the first. Now, I'll take 1, 3 and 3, 2. After that, I told you to cancel these both. Now, what is the element present? 1, 2. Is 1, 2 present in the above thing? Yes, it is present. Yes, it is present. Now, this 1, 2 is transitive. 1, 2 is transitive. Now, let us see for the other things also. Now, if I take 1, 2 and 2, 2. 1, 2 and 2, 2. 2 cancel and 1, 2 is present. So hence this pair is transitive. This pair is transitive. 2, 3 and 3, 2. So 2, when I take these both, this and this element will get cancelled. So it will be 2, 2. Yes, this element is transitive. This also is transitive. So hence we can conclude that this is transitive, right? So hence it is transitive. Now it is not reflexive, it is not symmetric, but it is transitive, right? Yeah. So if you have everything reflexive, symmetric and transitive, that is known as equivalence relation. Now this is known as non-equivalence relation because two of them is not satisfied. So hence it is known as non-equivalence relation. So that was all about the types of relations, and if you like my video, please do like, share and subscribe to my channel.